Hello, thank you so much for listening to my presentation. The title of my presentation is Non-Destructive Evaluation of a New Concrete Bridge Deck Subject to Excessive Rainfall During Construction, with Implications for Durability in a Cold Region. I'd like to thank my advisors, Dr. Spencer Guthrie and Dr. Brian Mazzeo, for their assistance in this research. The outline of what I'm going to talk about. First, I'll talk about concrete bridge deck durability concerns. I will then talk about non-destructive evaluation techniques that my team used in this study. I will then talk about procedures that we used for statistical analysis of the data that we gathered, the results from our statistical analysis, interpretation of our results, and the application of our results. I will then offer a summary and a conclusion. A newly constructed bridge deck in a cold region must be both strong and durable, with low permeability to water and chloride ions from de-icing salts. We were exposed to a newly constructed bridge deck that, while it was being poured, it was subject to excess rain from rainfall, excess water from rainfall. Excess water mixed with the concrete during construction can lead to problems such as high permeability, which can cause low concrete strength and low durability. Now, the concrete was constructed beginning in section A, and as they progressed to section C, during the pouring of around section C, they had about 0.3 inches of rain pour onto the concrete. So my team, we set up a test grid pattern after the concrete had dried with 10 points in each section. And we measured we used non-destructive evaluation techniques where we measured surface temperature, concrete cover depth, and that is the upper left orange measuring device, resistivity, using a 4-prong resistivity measurement device shown in the upper right, Schmidt rebound number shown in the lower left, and vertical electrical impedance shown in the bottom right. A vertical electrical impedance, this is a very new technique, measurement technique, that I have extensively studied as part of my thesis and my research. So it's something that's very near and dear to me. Resistivity and vertical electrical impedance are measurements of concrete permeability within the cover depth over the transverse and longitudinal rebar in the top mat of steel. Schmidt rebound number is a measurement of the compressive strength of the concrete surface. Using an analysis of variance, or ANOVA testing was performed on the collected data to determine if statistically significant differences were present between the 3 sections of the bridge deck. This table shows the ANOVA results to give you an idea of the data that we were dealing with. We see average values from sections A, B, and C with cover depths around 3 inches, deck temperatures around 100 degrees Fahrenheit, resistivities around 16, 17, 15 kiloohms per kiloohm centimeters, vertical electrical impedance in 4 to 5 magnitudes, and rebound numbers of about 50. So the ANOVA results showed that when it came to resistivity and vertical electrical impedance, which again assess the permeability of the cover deck, the ANOVA test did not indicate any statistically significant differences between the 3 sections. However, for the rest of the measurements, the ANOVA tests did indicate statistically significant differences among the 3 sections. So what does this mean? How did we interpret these results? Section C had a lower rebound number, or surface compressive strength, than the other sections. The section C also there was no difference in resistivity or vertical electrical impedance than the other sections. Now, as a reminder, Section C experienced the most rain during construction. What we took as our conclusions for this, this data was that the excess rainwater that Section C experienced rose to the surface of the concrete due to vibrations of the concrete during placement, and that only a thin layer of the concrete at the deck surface was affected by the rain. This would explain why the Schmidt rebound number differed, but not resistivity or vertical electrical impedance. This conclusion that we drew was confirmed with petrographic analysis, which is a very accurate destructive test where they actually remove cores from the bridge deck and take it to a lab and study it under a microscope. With the results that we drew from our non-destructive tests and also from the destructive testing that was done, the upper approximately 3 millimeters was milled from the deck surface before a polyester or polymer concrete overlay was applied to seal the deck against water and chloride ions. Non-destructive testing enabled the owner to confidently accept the deck without having the contractor have to demolish and rebuild, which they would have had to do if they were skeptical about, if the owner was skeptical about the durability of the deck. These techniques demonstrate the usefulness for assessment of other bridge decks, for which evaluating the ability of water and chloride ions to penetrate the concrete and quantifying the overall protection of the reinforcing steel are important objectives. To summarize, this study demonstrated the application of non-destructive evaluation techniques, including the new vertical electrical impedance technology for quality assurance of a newly constructed bridge deck subject to an unexpected rainstorm. A statistical analysis was performed on the collected data. The data allowed determination of the extent and depth to which the concrete was affected by the rainfall. The results were validated through a petrographic analysis. A simple, comparatively inexpensive surface repair was able to be implemented. At the conclusion, I would love to acknowledge funding received from infrastructure research that helped make this research possible, as well as assistance from Robert Stevens and Adam Guthrie in data collection and analysis. This is my contact information, Enoch Boekweg, as well as my advisors, Dr. Spencer Guthrie in the Civil and Environmental Engineering Department at Brigham Young University. If you have any questions, please feel free to reach out to either of us, and we would love to talk to you about this research. Thank you so much.